Okay, I've already started the review, and then I realized I like it better with some light on it. So we're going to do the chemical names and formulas test review, study your homework notes and bell ringers as normal. The test will look similar to other tests in the past with matching, multiple choice, calculations, and application problems all mixed in. So the first one I've already done, and then I realized I want this light, so it'll be easier to see. But basically, the periodic table contains all elements arranged according to similarities in their properties, and we've known that since like day one almost. The next question, the blank are on the right side, so that's the nonmetals. Okay, and then the blank are on the left side of the staircase, and that's the metals. Although blank is on the left, this is hydrogen. So blank is on the left, it is not a metal. Wow. I'm supposed to be writing hydrogen. I don't know what I was writing, helium or something. Okay. E, the two types of compounds are blank, and that is ionic and covalent. Okay, blank compounds are formed when atoms transfer electrons, that's ionic. Atoms that gain electrons get a blank charge. So if you're gaining electrons, which are negative charge, you're gaining a negative charge. And metals tend to form ions with a positive charge. Okay. Blank are huge conglomerations of positive and negative ions in a three-dimensional. This is a crystal. Crystal. Oh, gosh. Good thing I'm not a teacher, so I don't have to spell correctly. Okay. J, molecular compounds are formed when atoms blank electrons. So molecular compounds are when they share electrons. So remember, ionic compounds are transfer of electrons. Covalent is sharing electrons. Okay. A blank is an electrically neutral group of atoms that act together as a unit. That's a molecule. Okay. L, molecular compounds are formed when blank bond together. So that, remember, molecular compounds, that's also considered covalent. And covalent are formed when nonmetals bond together. Of the two types of compounds, blank compounds have a much higher melting point. So in this test, you do need to know the melting points like which one's higher. You need to know electric conductivity. You need to know all of those characteristics that we say at the beginning of each of those lessons. It will be on the matching, I promise, and the multiple choice. So of the two types of compounds, ionic compounds have a much higher melting point. All right, N, blank compounds are good conductors if they are dissolved in water. So this is the aqueous and this is ionic compounds. We saw this in a lab. A and blank indicates the makeup of a compound. So that's the chemical formula. And P, the empirical formula. Okay, this has been going on for 2 or 3 units now, the empirical formula. It is that reduced whole number ratio in an ionic compound. Q. Blank formula tells the exact makeup. This is molecular. Okay, now we're to the application type questions. So it says write the formulas for the following ionic compounds. So we have, here we go, potassium. So potassium nitride is a ionic compound, not only because it says it here, but because this is a metal and a non-metal mixed. So potassium has a +1 charge. Nitride is here. It has a -1, -2, -3 charge. And you bring these charges down, and you get K3N, which is your formula, okay? I'm just going to kind of go through these a little more quickly. So yeah, calcium oxide, Ca, calcium has a +2 charge, oxide has a -2. So when you bring these two down, it's going to cancel out as far as the ratio will be the same. So it's a 1-to-1 ratio, and that's your answer. Gallium chlorate, Ga, gallium is a +3 charge. Chlorate, this is chloride, okay, so chlorate is actually on our polyatomic ion sheet. Chlorate is ClO3 with a -1 charge, ClO3 with a -1 charge. So you're going to bring those charges down, so it'll be Ga1, but we don't write that. ClO3, and then the 3 comes down here, so that's your answer. Okay, magnesium phosphate. Magnesium has a +2 charge. Okay. Phosphate, this is phosphide. Okay, so we're going to phosphate, which is here. Okay, phosphate is PO4 with a -3 charge. You're going to bring the charges down, and you'll have Mg3, PO4, 2. All right, silver sulfate, so silver is here. It has a +1 charge. This is sulfide, so this is not sulfate. We want sulfate, which is here, and it's SO4 -2. Okay, charges will be brought down. Ag2, SO4. And you could put that in parentheses with the no 1. You don't want to put the 1 as subscript ever, but you could put it in parentheses if you wanted. All right, iron sulfite. So if you guys notice, iron has multiple possible charges, okay? So I don't know if you can see that any better. Okay. Iron has multiple possible charges, which is a +3 or +2. This indicates what that charge is right there. So Fe +3. And it's always a plus because it's always on a metal, okay? So anytime you see a Roman numeral, I know I've told you this in the lessons, but it's a plus charge because it's a metal. Metals are all cations, which means they all have positive charges, which also means they're all on the left side of the staircase. Okay, sulfite, that's not sulfide, so it's not this one. Sulfite is right here. Okay, so SO3 -2. We're going to bring charges down. Fe2, SO3, 3. All right. 10,5 carbonate. So 10, which is SN. Almost forgot. Actually, is that Fi? 10 SN. Nope, that's a 4. +4. I need to know my Roman numerals better. Carbonate, that's a polyatomic ion. Here it is. Okay, carbonate, CO3 -2. So we're going to bring the charges down. SN, 2, CO3, 4. Now I want you to notice this. so I've done something wrong. You need to, well, I'm not going to erase it because you guys would have wrote that. Make sure you know, guys, for one, I am like just running through these and I haven't actually done them yet, so some of them catch me off guard whenever I throw a trick one in there, so sorry. And for two, you need to make sure you reduce this. If it's an ionic compound, make sure it's reduced to its empirical formula. So it needs to be SnCO3 2, okay? That would be the answer you would get full credit for. I would probably do about half credit for this one. So make sure that once you've done it, just kind of take a look at your subscripts to make sure that you haven't screwed that up. And also, saying that, nope, I'm okay. Okay, so zinc oxalate. So zinc, let's look. It must only have one charge because it didn't indicate which charge. So zinc, right here, yep, a +2 charge. Oxalate, that's obviously definitely not on the periodic table. Oxalate right here. C2O4 with a -2 charge. C2O4 with a -2 charge. Okay, sorry, I got a phone call. Okay, so these two should cancel out, and it will just be zinc C2O4. Don't reduce that. These are covalently bonded, okay? So if you remember from class when I told you all of these polyatomic ions are actually covalently bonded, if you'll notice all of them are nonmetals, that will help you know that these do not reduce. Okay, cobalt permanganate. So cobalt +3 charge. Permanganate is not on the periodic table. Here it is. So it will be permanganate MnO4 with a -1 charge. So the charges will go down. So you have cobalt MnO4 3. Okay. Lead. Oh, that scared me. I thought I put, okay, I put the right symbol here. Lead is Pb. Almost put the wrong symbol. So lead is Pb here. It could have two possible charges in the Roman numeral indicated, so it's a +4 charge. Pb +4. Fluoride, so that's just the regular old fluorine that's on the periodic table. Cross it down, we have PbF4. All right, name the following ionic compounds. So now we're just naming them. This is super easy. The only difficult thing that I see, or that I would say to watch out for, is when there are multiple charges like this one. This is where we have to find out how much the anion side of the molecule is, and then have to even it out. I'll show you when we get there. So sodium bromate, bromate, I don't know if that's bromate, BrO3. So basically we're now going backwards and we're finding BrO3. Here it is. So, oh, it is bromate. Okay, so bromate, so, and sodium. So you're just going to literally write sodium bromate. Okay, and then the others are easy. This one's the only weird one. So potassium arsenate. I got arsenate from here, okay. Strontium. And then NO2, which would be right somewhere. NO2, so nitrite, so strontium nitrite. And this is magnesium, HSO4. HSO4. So magnesium hydrogen sulfate would be its name. So Okay, and then here's where you want to, this usually will get the students, they tend to not recognize that this nickel has multiple charges. If you look, nickel is a transition metal, which many of them have, which many of them have multiple charges. So nickel is right here, and it could be a +2 or a +3 charge. So we need to find out which one, +2 or +3. So I like to make this little cross section T chart, I don't know, whatever you want to call it, for the anion side and the cation side. Okay, so the negative side, you have chlorine, which everything in that group 17 that chlorine's in is a -1 charge. So, and I have 2 of them. So I have 2 -1 charges, and that means I have a -2 charge total on the anion side. So on the cation side total, I have to have a +2 charge because this has to be neutral. I only have 1 nickel, so it has to bear all the +2 charge. So that means the name will be nickel Roman numeral 2 chloride. And so that's how you would do that. This is just barium phosphide. You just change the ending from phosphate, phosphorus, I'm so sorry. Change the ending of phosphorus to ide. Okay, so moving on down, more of these will have those Roman numerals. How many more do we have? I'm going to skip a couple that are obvious. All of these are obvious. Here's one that is a transition metal. And remember, this is the only cation that is a polyatomic ion, ammonium, okay? So NH4, so it would be ammonium sulfide. I'll go ahead and write that one since it's unique. Okay, this one is tin, but if you'll notice on the periodic table, tin has multiple charges, okay? It could be +2 or +4. So tin, you'll have to indicate, but not fluoride, okay? So fluoride has -2 charge total, so that means this is a +2 charge total. And there's only 1, so that means the Roman numeral will be 2. So tin, 2 fluoride. Okay, mercury, same thing. If you look at mercury, it can hold 1 or 2 charges. So bromine or bromide has a -1 charge. There's 2 of them. So altogether, this side is a -2, so this side has to be +2. So a +2 charge has to smear out between both of these mercuries. So really, it's +1 each. So that would be Hg, or mercury, oops. Okay, so mercury, what did we say, 1, and bromide. Okay, let's do a few more and then we're just going to move on. Let's do lead. Lead, I know, is a multiple charge bearing atom. Lead can be +2 or +4. So let's look at what this one is. NO3, we have to find that on the periodic table. Down here. So NO3 is nitrate. Oh, I forgot to look at what charge it was. -1 charge. Do y'all see that? It's a NO3 is a -1 charge. So you have 4 NO3s, so that'll be a -4 charge total. And then that means this side will have to be a +4, and there's only 1 lead, so it'll be lead 4 nitrate, wouldn't it? Yeah, nitrate. So that would be how you would name it. All right, we're going to move on from this. There's a lot of examples of that. Let's move on to the molecular compounds. Remember, guys, molecular also means covalent, which means that you need 2 or more non-metals. I'm writing it out and I'm stressing it because on the test, there is a section of the test that just mixes everything together. It mixes ionic compounds, covalent compounds, and what's it called? Acids. And you just have to, it doesn't tell you this in bold capital letters what you're naming. You have to figure it out yourself. So it's covalent, and covalent means that you have 2 or more non-metals bonded together. I found these really easy to name. So silicon tetrabromide. So you really just need to know those prefixes right here, okay? And then you're good. So silicon, there's only one of them, okay? Tetrabromide, that means there's 4 of those. Tetra means 4. This next one, diselenium, so there's 2 seleniums. Hexafluoride, that means there's 6 fluorines. Okay. Phosphorus, we don't write mono, so I know it's 1 phosphorus. Pentachloride, so penta means 5. That's you can tell right now that that is the trigonal bipyramidal shape. Arsenic heptaoxide, so arsenic heptaoxide, so arsenic is AS, I think. I just want to make sure. Yeah, arsenic AS, and it's just one of them. Heptaoxide, so oxide is O, and hepta is 7. Sulfur trioxide, so sulfur trioxide, tetra 4, deca 10. Okay, so Br4, I 10. Diiodine, nona chloride. Oxygen, dichloride. Okay, so those tend to be pretty easy. I feel like the most difficult ones that, especially last year when the kids took their test, this is where they really lost a lot of points, is being able to convert the formula to the word equation and figuring out what that charge is. Okay, name the following molecular compounds. So this is where you're just going to do what we did just a few numbers ago, but backwards. So this is trisulfur. 9 is nona, so Nona oxide. Okay. This is silicon. We don't do mono on the first one. And then tetra is 4. Tetraiodide. Okay. This is di and hexa, so disulfur hexaoxide. Oops, hexachloride. My bad. Okay, this is iodine. And there's 7 bromines. So iodine, hepta, bromide. Okay, this is antimony. And there's 3, so trichloride. Okay, next one is tetra and deca. So okay, this is nitrogen trichloride. Arsenic, pentafluoride, tricarbon, octo or octa, I'm getting the Greek words mixed up, octa, octahydrogen. That's a very weird name. Surely I made that one up. Then tellurium hexachloride. Okay. So these are easy. I feel like if once you guys, and the Greeks will really know most of these, but once you know the prefixes, then it's pretty easy. Write formulas for the following acids. So also this is the second most difficult in my opinion as far as when I'm grading. I noticed mistakes. So remember the rules for naming acids, hydroic, okay? The original ending was "ide." If it is just something ic, the original ending was "ate." If it was something ous, the original ending, can y'all even see this? Okay, I'm sorry. The original ending was "ite." Ite. Okay. So we have chloric acid. So chloric acid. So obviously every single one of these starts with H, right? Because this is what the definition of an acid is. So it's going to start with H. So we're just trying to find out what it is bonding to. What is that H bonding to? And what is, since H has a +1 charge, the ion is going to have that +1, the 1 subscript. So really all we're trying to do is find out what the H's subscript is and what the original ion is. So ic, okay, so it was chlorate. So the original ending was chlorate, ClO3 minus 1. ClO3 minus 1, and they're going to, it'll be H. We don't write the 1, it's just a 1-to-1 ratio, so it'll be like this. Okay, hydrobromic acid. So you have hydroic, so that means it was bromide. So that's just on the periodic table with a -1 charge. Okay, phosphorus acid, so OUS. So then the OUS, the original ending was ite, so phosphite is what we're looking for. Here it is, PO3 with a -3 charge. So you'll bring the charges down. H3, PO3. So you notice how every single ion will have just a 1 subscript. So really we're just looking at the charge on the ion, and that's what will be the H's subscript. Okay, chlorous acid, so OUS, it ended in ite, so chlorite. Here, ClO2 minus 1 with a -1 charge, so that's not really going to be a different subscript than 1, so that's it. Bromic acid, so ic ended in 8, so we need to find bromate. Bromate, right here with BrO3 minus 1. So it's a 1-to-1 ratio, BrO3. So that's it. Okay, now we need to name the following acids. So ASO4, here. Okay, so it's arsenate. Oops, y'all can't see that. Arsenate, okay. So 8, okay, so now we're going backwards, right? 8, that means it needs to end in IC. So instead of arsenate, it's arsenic acid. Have you heard of that? Okay, now ClO2, so we need to find that one. ClO2, you're probably staring at it. Here it is, okay? So that's chlorite, okay? So we need to find ite. Now the ending needs to be changed to OUS, so chlorous acid. Okay, HF, so the ending, this is from the periodic table, the ending is ide. So if the ending was ide, that means it's hydrofluoric acid. Okay, and then next, HHS. This type of question usually gets people because of that. But you just find the ion HS and no big deal. Once I find it, here it is. It's right here. It's bisulfide, so it ended in ide, bisulfide. So it needs to be hydrobisulfic acid. So hydrobisulfic acid. HClO, okay, so HClO, so I just need to find ClO right here. And that was hypochlorite. So the ending was ite. We need to change it to us, whatever. Hypochlorous acid.